So in this flip class video, we're going to introduce the product and quotient rules, which will greatly expand our ability to take derivatives. So these are super helpful for us. So we're going to introduce what these rules actually are, and then give a few examples of how to use them. So let's consider if we have a product of two functions. So in this case, we'll say h of x is the product of a function f of x and a product of a function g of x. And f and g are both differentiable functions here. So you might like to ask, what is the derivative of h of x here? And is it related in some way to the derivative of f of x and the derivative of g of x? So the most naive way to think about this would be to say, well, it should just be the product of f of x, derivative of f of x, and the product with the product of the derivative of g of x. We saw in the last section that if I have f plus g and I take the derivative, that's just the derivative of f plus the derivative of g. So maybe it works the same way with products, and this will all be very simple. So let's take a really simple example here. We'll take h of x to be x squared, and then we can take f of x to be g of x to be x. So f of x times g of x is x times x, which is x squared, which is h of x. So we know from the previous section that if I take the derivative of x, I just get 1. So the derivative of f and the derivative of g, those are both just 1. However, we know the derivative of x squared is 2x. So 1 times 1 is 1, which is definitely not equal to 2x. So our naive guess here that it should just be the product of the two things isn't really going to work out. So there's going to be something else that comes into play here. So it's a little bit more complicated than we think, but it's not too bad. So the product rule here says if I take two functions and I take the product of those and take their derivative, you take the derivative of the first function and multiply it by the second function, and then add the first function times the derivative of the second function. So if you think about what's changing here, you're getting a little change of f times g plus f times some change in g here. So let's go ahead and see how this works. So if we take f of x to be x squared plus 3x plus 2, and g of x to be x to the 50th plus 2x to the 7th plus 3, and let's take the product of those two things. Now, we could take that and we could FOIL it all out, and we would end up with a polynomial, and then we'd know how to take the derivative of that polynomial. But we can also just avoid FOILing this out and use the product rule instead. So I have the derivative of f of x is just 2x plus 3. The derivative of g of x is 50x to the 49 plus 14x to the 6th. So then I can get the derivative of h by using the product rule. So it's the derivative of f, which is 2x plus 3, times g, x to the 50th plus 2x to the 7th plus 3, plus f, which is x squared plus 3x plus 2, times the derivative of g, which is 50x to the 49 plus 14x to the 6th. And we can leave it like this. We don't need to simplify it any further. So you see that saves some time from FOILing everything out. And in different cases, it could be a lot more complicated than just FOILing out two polynomials as well. So the next thing we might be interested in is if I have two differentiable functions, what is the derivative of the quotient of those two functions? So the quotient rule is a bit more complicated. So in this case, we saw in the product rule, it didn't really matter. We could have switched the order of which we added them. But in this case, it makes a difference. So the derivative of the quotient here is the derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by the bottom squared. So it looks complicated, but you'll do enough of these that this will be pretty easy to memorize once you've done it enough times. So let's look at an example. Let's suppose I have the function h of t being 1 minus 2t over 3 plus t, and let's find the equation of the tangent line at t equals 1. So that means we're going to need the slope of the tangent line. We can get the point on the tangent line by just plugging in t equals 1, which we'll do in a moment. So if we plug in that 1, we see that this h of 1 is minus 1/4. So the point on the line is 1 minus 1/4. So the only thing we need left to find is the slope of the tangent line. So we're going to use quotient rule here. So we let f of t be 1 minus 2t and g of t be 3 plus t. So that way we can realize f is the quotient of f of t minus, or over, divided by g of t. So now our quotient rule says we should have h prime should be the derivative of f, which is negative 2, times g, which is 3 plus t, minus f, which is 1 minus 2t, times the derivative of g, which is 1, divided by g squared, which is 3 plus t squared. So we FOIL this out and simplify, and we see the derivative of h is minus 7 over 3 plus t squared. So putting all that together, if we plug in 1 into the derivative, we get minus 7 over 16. So our tangent line is y minus minus 1/4, which is y plus 1/4, is equal to minus 7 over 16 times t minus 1. So that gives the product and the quotient rule pretty quickly there, and gives an example of each. Obviously, we'll spend do quite a few more examples in the regular lecture, but this just gets you started so you've seen it before we get to the regular lecture.